Hey everyone. So we're going to carry on with our conversations around quadratic functions. In our last lesson, I introduced to you what a quadratic function was and the shape it looked like. And we focused on one particular form in the last lesson, which was called standard form. Today, we're going to move our attention to a new form called factored form. A factored form sounds, or it is, just like it sounds. You've got some factors, binomial products being multiplied together in your equation. And we got to figure out what those factors tell us and how they're useful. Okay, so that's what we're going to do today. So first of all, you will recall a quadratic function is in standard form when it looks like this. Y equals ax squared plus bx plus c, where a, b, and c are real numbers. I just hid myself for a sec so you guys could all see the words. The graph of a quadratic relation is called a parabola. Every quadratic function has the following. We've got a vertex, which is where we change direction. So it's the highest or lowest point on the curve. Either you're coming from descending to ascending, and at the vertex you change right there, or you're going from ascending to descending, and at the vertex, that's where you change. A maximum or minimum value, so that's the highest point or the lowest point, and then a y-intercept, okay? Why don't all functions have x-intercepts? Well, in order to have an x-intercept, we talked about this a little bit yesterday, I essentially need to have my vertex and direction be such that I'll hit the x-axis, right? Here, I have my vertex and direction such that I'll have two x-intercepts. But if I was to have my vertex here, but the direction down, you'd notice I don't have any x-intercepts there, okay? So not all quadratics will have x-intercepts. Okay, and so this is just a quick picture of all of those important points that we have. So we have our axis of symmetry drawn as a dotted line here, okay? And then we have our x-intercepts here and here, the y-intercept, and the vertex. All right, awesome. Okay. In this graph, you have this in your book, list the coordinates of the x-intercepts for each graph. Okay, so point 1, I've given you, it's -5, 0. Then we're going to scoot over to point 2, which is over here, because it's the other x-intercept of the red graph that I'm showing you. And that would be the point 1, 0. Then we have point 3 would be -2, 0, and point 4, 3, 0. Okay, all of that should feel pretty familiar to you, just grabbing points there. All right, now, what is similar about each coordinate? Well, the thing I want you to notice right off the bat is all the y values are 0. And that should be the case because I'm on the x-axis, right? Yesterday, actually, we had the same talk, except it was about the y-intercepts. All the x values on the y-intercepts were 0. Well, now all the y values on the x-intercepts should be 0. So the y value is 0. Explain if this will always be the case. Yes, it will. If I'm on the x-axis, I would have not moved up or down, so the y value would need to be 0. Okay? Use the x-intercepts to find the axis of symmetry for each graph. Okay, so here's what I need you to see. Let's just pick on graph 1 for a sec. The axis of symmetry is right there. And I know that I have an x-intercept at -5 and at 1. So my question to you is, how could I go use -5 and 1 and arrive at this value here of -2 for the axis of symmetry? What I want you to see there is it's the average. Okay, so to get that x equals -2, I would need to go -5 plus 1. -5 plus 1 is -4, and then divide by 2. Remember, when you're calculating the average of something, you add everything together and then divide by the total amount of items that you added. In this case, there's only 2 items, so I'm dividing by 2. Okay. Then this guy is x equals 1/2. This is the axis of symmetry for the blue graph that I've shown you here. For you, on your paper, it's the graph opening up. But take a look. I can do the same thing. I can take the average of -2 and 3. -2 plus 3 is 1, and then 1 divided by 2 is a half. Okay? Good stuff. So, is it only the x-intercepts that I can use? And that's actually an interesting statement. No, it's not just the x-intercepts. It's actually anywhere where it's the same horizontal piece. So if I took a look at this for a sec, this horizontal line here, I could take this point and this point. Okay, as long as they're on the same horizontal line, because these guys are symmetrical, the average will take me right back to the axis of symmetry. So take a look. This guy is -7. This guy is 3. -7 plus 3 is -4. -4 divided by 2 gives me that -2 that I originally had there. Okay. All right. Awesome job. So to determine the axis of symmetry using coordinates, find 2 points on the same horizontal line and find the average of those 2 points. Now, we like to find the x-intercepts just because we like to know what the x-intercepts are anyway, right? Usually when you're drawing a quadratic, you want to draw them and label your x-intercepts. So if you can figure out the x-intercepts, that's always helpful. So then if you already have the x-intercepts, you can take the average of them and get the axis of symmetry. Then if you had the axis of symmetry, you know the x value of the vertex, right? So if you didn't know the vertex, you could then plug in the x value of the vertex into the equation and get out the y value. Okay, I'm just going to hide myself right quick to make sure you guys all have the words at home. All right. So what if we don't know the x-intercepts and only know the function? How could we find the x-intercept? And the question is, or the answer is, factor it. Okay, let's go through factoring this equation here. F of x equals x squared minus 2x minus 3. I want two numbers that multiply together to give me -3, add together to give me -2. Those two numbers are -3 and 1. And so this factors into x minus 3 and x plus 1. Now, if you would rather go through decomposition, by all means, please do that. I haven't shown you the steps because there are different ways to factor. However you do it, though, you should get down to x minus 3 and x plus 1. If you're struggling with factoring, I do encourage you to go back and take a look at some of my 10C lessons around factoring, okay? That will help. Okay, now, we just had a conversation earlier, like the last slide, that anytime I want the x-intercepts, I know the value of y is 0. Well, where's y in this equation? F of x is y, right? So this guy here is my y. So if I want the x-intercept, I need to make that number 0. So we know that for all x-intercepts, the y value is equal to 0. So I make that 0 like this. Okay, now this is a statement that reads 0 equals a number times a number, something times something. Well, if something times something equals 0, like, let me just write this out for a sec. If A times B equals 0, doesn't that mean that either A has to be 0 or B has to be 0? One of them has to be 0 in order to multiply by 0 and get 0. This is called the zero product principle. When you have two numbers being multiplied together to get 0, one of them, at least one of them, has to come to be 0. So what I can do is I can say, okay, that means either my x minus 3 has to give me 0 and I can solve for x, or my x plus 1 has to give me 0 and I can solve for x. Okay, so the only way to get 0 is if one or both factors are 0. So I now can separate into two little algebra questions where each different factor equals 0. Okay, so then if 0 equals x minus 3, then x equals 3, and I have a x-intercept at 3, 0. If 0 equals x plus 1, I have x equal -1. I just bring my 1 over to the other side and isolate for x, and that gives me -1, 0 for that x-intercept. So now I know the two x-intercepts, 3, 0 and -1, 0. Okay. So when a quadratic function is written in the form y equals a times x minus r times x minus s, we say that that's in factored form. And the great thing about factored form is it's telling us very quickly those factors turn into where our x-intercepts are. Okay, so if we're in factored form, we can very easily figure out our x-intercepts. Okay, so find all the information for f of x equals x squared minus 2x minus 3. Now, this is the function I just gave you, so we've already factored it. So we're ready to go for that one. The y-intercept, remember we plug 0 in for x, or we understand that in standard form, it's just going to be that constant term. It's going to be the number all by itself, which is -3. I'm just going to quickly hide my face here for a sec, just to make sure everybody has the full question. Okay. So the y-intercept there would be 0, -3. I know I'm going to open up, and the way I know I open up, go back to our lesson yesterday, the a value is positive here. So if the a value is positive, I open up. X-intercepts we've already discussed. They were at 3, 0 and -1, 0. The work to back that up is on the previous slide, right? That's where we factored it and set them equal to 0. The axis of symmetry is going to need to be the average between 3 and -1. So 3 plus -1 is 2, 2 divided by 2 is 1. So I know that I'll have an axis of symmetry at x equals 1. Okay. Maximum or minimum value? Well, I know this graph opens up. And so if it opens up, I know there's a bottom to it. So I'll have a minimum value. And I know it will be the y value of my vertex. I already know the x value of my vertex. So what I want to do is plug in that x value. So f of x equals x squared minus 2x minus 3. I just substituted my x with 1 because I know that that's the axis of symmetry, which is the x value of the vertex, and the max or min is the y value of the vertex. Okay, so now I've got 1 minus 2 minus 3, which is -4. So I know I have a minimum at -4. My domain is real. Remember, all quadratics have a domain of x's, remember the reals. In my range, I have a minimum, so it'll be from the bottom up. So it'll be greater than, y is greater than -4, greater than or equal to. Okay, now I want you to go ahead and draw this graph. You have a grid on in your book. You want to label all the important points. So I want to see the point 0, -3 labeled, the point 3, 0, the point -1, 0, the point 1, -4 for the vertex. I want to see the axis of symmetry. Remember, the axis of symmetry needs to be a dotted line. Give you a sec to do that. And you can pause me if you need more time. This is what your graph should look like then. So we have my x minus 1 axis of symmetry, x equals 1 axis of symmetry. As a dotted line, I've labeled my vertex, I've labeled my 2 x-intercepts, and I've labeled my y-intercept. Okay. Awesome. See, that's not bad. Let's do another one. So now I've got -x squared plus 2x minus 3. Now, if you have a negative on the front, you're going to want to factor the negative out when you're trying to figure out your x-intercepts, okay? Let's deal with the y-intercept first. Y-intercept would be 0, -3. This one's going to open down because my a value is negative. Okay, and now we're going to try and factor it. So we're going to set it equal to 0, and we're going to try and factor. So we have 0 equals negative, and then I've got x squared minus 2x plus 3. When I took the negative out, all the signs switched. I'm just going to hide myself for 1 sec to make sure everybody has that. Okay, so I'm looking for two numbers that multiply together to give you 3 and add together to give you -2. So let's take a look at that. Sorry, I'm trying to switch the color of my ink here for a sec. Okay, so I've got 1 times 3, and that's it. Now, some of you may see that -2 and think, oh, okay, the 3 has to be negative. Well, the problem with that is I actually need to multiply to get positive 3. So I can't have one negative there, which actually means this is not factorable. Now, I want you to be very careful with my next statement, okay? At the moment, this is not factorable, and that tells us that there are no x-intercepts, okay? That is not necessarily true as we gather more tools in our tool belt, okay? There will be other things we can try when we can't factor to still figure out if there's an x-intercept, namely something called the quadratic formula that we're going to learn in a couple weeks. But for the moment, the fact that this is not factorable will tell us that there are no x-intercepts, okay? But that's not always the case. So I don't want you to hear, I want to make sure that's really clear. I don't want you to hear that just because something can't be factored, there are no x-intercepts. That is how we're going to play the game today. But later on, we will learn other things to do where we could find x-intercepts even though the function wasn't factorable, okay? So this presents a predicament for the axis of symmetry because I can't take the average of the two x values. Well, I already have 0, -3. So what I could do is I could figure out another point that will get me -3. Okay. So you could play around with that a bit. You could do some calculations. You could use your graphing calculator to help. The other point is 2, -3. If I plug in 2 here, I end up with 2 squared, which is 4. But then it'll be -4. And then I'm going to add to that 4, which is 0. And then I'm back to just -3. Okay. So to get the axis of symmetry, I got the other point that had a y value of -3. Now I have 2 points on the same horizontal, and I can take the average of those x values. So 0 plus 2 divided by 2. 0 plus 2 is 2, and 2 divided by 2 is 1. So I know I have an axis of symmetry here at 1. For my max or min value, I know that it's a maximum value because I opened down, right? And I know the x value of my vertex is at 1, so I plug in 1 to the original equation, and I can solve for y. So I have -1 plus 2 minus 3, which is -2. So now I know I have a maximum at -2. I know my domain will be real, and my range, well, if I have a maximum at -2, I'm going to be y is less than or equal to -2. Okay, now you're going to put all of that on a graph. You have several points that you can draw, right? You can draw 0, -3, 2, -3. You can draw 1, -2. Make sure your drawing is as accurate as possible, and make sure your shape is very decent, okay? I don't want straight lines. This shouldn't look like a V. That's actually something else. You want to make sure you come to a nice rounded vertex here. Nothing should be pointy or anything like that, okay? So I've labeled my vertex, I've labeled my y-intercept, and I've labeled my axis of symmetry here, okay? Good job, guys. Okay, let's do one more. So first of all, with this one, I'm just going to hide myself for one quick sec. Everybody's got the question. I know my y-intercept would be at 0, 6. And I know that I opened down because my a value is negative. Okay, to get the x-intercepts, I want to try and factor this guy. F of x is going to be 0 if I'm on the x-axis. And the first thing I'm going to do for the factoring is take out the -2. So I have 0 equals, I changed my y value to 0. And I factored out the -2. That leaves me with x squared minus 2x minus 3. Looking for two numbers that multiply together to give me -3 and add together to give me -2. This is actually now the same equation I gave you 2 examples ago. It is factorable. I end up with x minus 3 and x plus 1. Don't drop that -2 though, hey? That -2 has to stay in the front. Again, I'm just going to hide myself just to make sure everybody has that. And that tells me that x equals 3 and -1 because I took each factor, I set it equal to 0, and I solve for the x, okay? Now, the axis of symmetry will be the average of those two numbers because they're already x values from the same horizontal line. So I can go 3 plus -1 over 2 and get 1. I know I'm going to have a maximum value here again because my graph opens down, right? And I know the x value of the vertex, so I'm going to plug the 1, which is the x value of the vertex, into the original equation, so I get the y value of the vertex. because the y value of the vertex is that max or min point. Okay, so I'm going back to the original equation, and plugging in 1, I get out 8. So that tells me I have a maximum at 8. My domain will be real. All domains of quadratic functions are real. And my range, remember, we just said we have a maximum at 8, so it'll be 8 and down. So we say y is less than or equal to 8. Y is a member of the reals. Okay, now we're going to draw this. I'm going to take all these features, put them on the graph, and see if we can connect the dots into a nice parabolic shape. One thing I do want you to think through, though, this is the first time we played around with the coefficient on A, right? All we have done in that last lesson yesterday is we had A being positive or negative. We never threw a number there. So observe when you go to graph this, if you notice anything different about this graph, okay? You can pause me if you need some more time. The graph should look like this. So I've labeled all my important points. I've got 1, 8 for my vertex. I've got my y-intercept at 0, 6, and I've got my 2 x-intercepts, -1, 0, and 3, 0. And I have my axis of symmetry at x equals 1. Now, I don't know if you can notice it from my picture because I keep changing the window settings so that you see as much of the graph as possible, but this graph is actually skinnier. It's narrower than the original. So when we put an A value that's bigger than 1, we end up, the graph becomes narrower. Okay, it's called a vertical stretch. We'll talk more about it as we go, but yeah. So the higher A value actually made the graph narrower. This is called vertical stretch. Okay. So this isn't too bad today, right? We can handle this. We're going to survive math. All right, let's summarize together. So when a quadratic function is written in the form y equals a x minus r times x minus s, we say it's in factored form. The function will have a maximum if the graph opens. Well, if I need a top, the graph has to open down, and that works if a is less than 0. Okay, now the function will have a minimum if the graph opens. If I need a minimum, I need to open up so that I have a bottom. So it will open up, and that works if a is greater than 0. The x-intercepts will be at, well, remember I gave you this form right here. So if I set this factor equal to 0, I have x minus r equals 0, right? Because this is the zero product principle, and I'd end up with x equals r. Okay, same thing here. If x minus s equals 0, x would equal s. So I can say that my x-intercepts will be at r and s. Now, remember that those should be coordinate points if you're asked for an x-intercept. So it would be r comma 0. Let me just write that in just to make sure we're all on the same page. R comma 0 and s comma 0. Okay, s comma 0. Okay, and then the axis of symmetry would be the average of those x-intercepts. So to get the average, we add the two things together and divide by 2, and there's only 2 things we're adding. So that's r plus s over 2. Okay, r plus s over 2. Everybody doing okay with there? Okay. Remember, you can always pause. The great thing about videos is you can shut me up anytime you want. Pause, you can rewind, okay? Make sure you're getting this into your head in such a way that it sticks, that it makes sense to you, okay? The coordinates of the vertex can be found by subbing the axis of symmetry value back into the function. That's what we've been doing for these last 3 examples. And then the y-intercept can be found by letting x equal 0 and solving for y. Okay? Awesome. All right, so if you're my kid at school, here's your task now. Please make sure you're doing your homework. Make sure you're checking your homework, checking the answers. Your steps in your homework should look like my steps in my answer key. That means you're communicating everything that I need you to communicate, okay? As always, if you have any questions, make sure you come and chat with me, okay? That's what I'm here for. And I love those chats. I love questions. All right? You guys got this. We'll see you for the next lesson where we're going to deal with some table of values and graphing technology, okay? Until then, enjoy. Bye-bye.